my attention before we start?
Nothing from my side, sir.
Fine. The rest?
We can start.
Fine. So
I think we can start, sir.
all right. I'm sharing the screen so that we can also follow as we go. Can you see it?
Yes.
Okay. So I think the last time we talked about polymorphism, I'm sure. When we want to talk about polymorphism together with inheritance, that correct?
Yes.
Yeah.
Okay. So in that case, we also went on to talk about constructors and destructors and the orders execution when we're dealing with base functions and derived base classes and derived classes, right?
Yeah.
Yes, and we say when we are creating an object of a derived class, we run the constructor of the base function first, then we run the constructor of the derived function, but then when we are destroying the object, we move in the other direction. We start with destroying the destructor of the derived class, then the destructor of the base class, right?
Yes, sir.
Okay. So now we'll shortly look at the issue of multiple inheritance and also where classes can also inherit from derived classes. If you look from the screen, you see that we have class A, which would be our base class, and then we have class B as a derived class of class A. And then we have class C being also derived from class B. So it's like a chain of inheritance. And we'll just show a program whereby one class can inherit from the other, and the other class can also be inherited from. That's like in the natural sphere of inheritance. I always give examples of your father inheriting from his father. You can also inherit from your grandfather. So that's the scenario that we are giving, class A, B, C. So in this case, we just show a class whereby we are inheriting from a derived class, right? So we can derive a class from a derived class. So we expect to have created a class called fit distance. And then from fit distance, we want also to derive a class called inch distance. And there we are showing its data members. And in that case, it's a protected data member called float. And from float, we also have another, the member functions, set distance, get distance, and get fit. Whereby the get distance is the one which will return the inches, and the get fit will return the feet. So that's our class inch distance, which we are inheriting from class fit distance. So in that case, we can create an execution program, the C++ program called inch distance. in this case, we are now defining set distance member of the class inch distance. So you remember our scope operator, a double colon. So in this case, we are saying the set distance, which we call, which is an argument of type float. The argument is inch. It will be the member function for the class inch distance. And then it redefines inches as equal to in, and we also again define the set distance function, but in this case it is the function for the class feet distance that will be calculated from inches over 12. So in this case, the base class feet distance, the one in which we are calling that function. Then we then go to the main program, but in this case, we have assumed that the inch distance and the feet distance programs have been compiled and linked to the program. So just move on and include the data function inch distance and the data manipulation data file in C++. So now we are now defining inch distance, inch, and another variable float is in. Right? So in this case, we are creating an object of class inch distance, which is called inch. Then we prompt our user to enter the distance in inches, and then want to convert it to feet and miles. And then our cin function will take in that input is the inch, right? Then the inch dot set distance in. So if you look at inch now, you say inch dot set distance, it means we are now running the inch distance set distance member function, because inch is an object of plus inch distance. Then see out here we are just showing the manipulation of the data, how it should appear when we are giving the output. Then we say inch dot get distance, which means the get distance that you run will be from the inch distance class. The get feet also from the inch distance class, the get distance from the inch distance class, and the get miles from those. In other words, we are just capturing the input of the user. Then in that case, in demonstrating the program, when you enter the inches, in that case, they need to run the 2 and convert your feet to inches. So that's how we show that you can derive from more classes. But then when it comes to multiple inheritance, we are saying now the class is inheriting from more than one base function, right? That is multiple inheritance. In human beings, we talk about that you inherited from both your mother and your father, and the mother and the father are two different classes, but you can still inherit from them. That is now multiple inheritance. And we give a program to demonstrate that. So in this program, we are defining the date data file. We define our class date, protected data members, day, month, and year, the public member functions. We have date, which is our constructor, because it's the same name as the class, and it takes the variables or arguments is day, month, and 1 year, and all the 3 should be integers. In this constructor, our day becomes equal to D, our month becomes equal to M, and our year is equal to 1. Then int get day, we return the day, get month, we return the month, get year, we return the year. Then you declare another class called time, which is member functions hour, minute, and second, and it is also its constructor time, which takes hour, minutes, and second as its argument or parameters. and they are all of type integer. So hour will now be equal to h, minutes will be equal to m, second will be equal to s. Then you also get the get hour, which returns the hour, get minute, which returns the minute, get second, which returns the second. So we have actually defined two base classes. So we'll now create a third class from which will inherit from the two base classes. That way we'll be demonstrating our multiple inheritance. So our third class called date time, right? So we have to include date.header and time .h. Excuse me, let me admit someone here. All right, it's done. All right, so I was saying we now include the date and the time header files because we want to use those two when you are now declaring the date and the time classes. This is nothing new. We have talked about the header files in our previous lectures. Then we have our class called datetime, which is inheriting to the public interface from date and also from time. So you can see that this is inheriting from two classes. And this part is the part which shows your multiple inheritance, that this class is inheriting from two classes. Then we define its data members, DT string with 10 characters, then public member function, date time, which takes 6 arguments. And if you check it, we take arguments from the date and class, which are 3, and the time class, which are 3. Then void get date time to return there's a pointer to a string, is its parameter. Then string copy, string and DT string. This is the function which will copy the text from there. Then we now implement that using the datetime C++ function. So
Hello, sir.
Hello.
Can you go to the previous slide?
The previous, yes.
My network had been acting up. You mentioned about something about us knowing how we know it has been inherited for multiple classes. How do we know?
Okay. So this is our class, right? Class date time. Then we
Yes.
have that colon. Then we have public date. That means it's inheriting from date, right? And in the same line, we say public time, which means it's also inheriting from time. So that is the line which shows our multiple inheritance.
Thank you.
Okay. Can we proceed?
Yes.
Right. So we are now having our implementation class, datetime.c++. So again, it includes the datetime header file. So you know by default, if you include the datetime header file, the datetime header file also includes hold a bit. Right. So I was saying, if you include the datetime header file, if you go back to the datetime header file, it includes the date and the time. So it means it will also, when you are implementing it, it will also include those header files. So you just want to include the one that you need immediately, which is the datetime header file. Then the string header file, that is for the string copy and string concatenate functions, which are functions you get from the C++. Then the standard library header file. Then void date time. And you see there is another date time here. And date time is a class, meaning to say this will be what? A constructor, right? And it takes all those parameters as shown before. And then this is the base plus a constructor date, which takes day, month, year.
Ndikuva Felicia. This real saving
Can you mute that? Okay. Can you proceed? Right. So I was explaining how you define your constructor of your derived function. So our constructor for the derived, for the derived class, our class is datetime, right? And then its constructor is datetime, which takes the day, the month, the year, the hour, and the minute, and the second is its parameters or arguments. And then we also define again the base class constructors, which is day, month, and year for the date, and the hour, minute, and second for the time, right? So we have given this function, so that is our constructor for the date time function. So what it does, creates a temporary work area, then it stores the data in the DT string in the form of month, day, and that. So if you look at it, it takes the current what? The current time and date, right? And it saves them in the temporary work area. However, you can choose to save it anyway, not necessarily saving is temporary and the like. An option to save in another way, right? Then this also will take the time in terms of hour, minutes, and seconds, and we take the get hour, get minute, and the get second, right? Then we now create our C++ class, which demonstrates how we deal with multiple inheritance, right? So datetime.c++ must be compiled and linked with this file. I'm sure you still remember how we did those issue of interfaces. Using those data files that you run and you compile, then you start using those files at a later stage. So in this case, we again include the datetime data file. In our main function, we have a formatted character string of characters. Then it is datetime, first date. So if you look at this, you realize that takes the dates from the system. Then it gives out the formatted dates from there. And that will be the program output. Now, someone had a question when I was dealing with these base class and derived class constructors. So there is a rule that says that the derived class constructor should take many parameters enough to pass to the base class. So if you give less parameters in your derived class, then your program might not run. So if you think that those parameters are not useful when you are running the base class constructors, you just initialize everything to 0. Like here, let's say you only needed the day, the month, and day, and you didn't care about the hours. In your constructor, you just initialize the hours and the minute and the seconds to 0. But it seems as if you need many parameters so that you can pass them to all the base class parameters. That is if your definition is like this. But remember, you can also create your own constructors in your base classes. You don't expect to use them in your derived class. And in that case, it will follow the order which we talked about when you're executing the constructors and the destructors for that. Right. So that will also help us, let's say in your project, if you wonder how you can now derive a a class from more than one class, you can still do that through following the issue of multiple inheritance. Right, so that's it with multiple inheritance, unless if we have some questions to answer. Do you have any questions, or you want to look at it on your own? Hello?
No questions.
No questions yet.
No.
Okay.
Someone asked a question who's not able to join.
What was the question?
Okay. Is it possible? It's polymorphism. Later.
You can ask now, because after this, you want to do arrays.
Okay, constructors and destructors demonstrate runtime polymorphism, right? Provided that there's dynamic binding involved. How best can we create objects which rely on constructor arguments and neglect other functions under public domain of the base class? Let me copy that.
We are reading a question, is it?
Yes.
Yeah, that's why it was. Okay, can you go slowly so that I can pick the bits?
I sent a message.
Okay. The first question saying they demonstrate runtime polymorphism provided that there is dynamic binding involved, right? In our base, can we create objects which rely on the constructor arguments and neglect other functions under public domain, the base class? I think when you are creating an object of a class, it's not advisable to use the arguments in the constructor. Remember, the constructor runs once and when you are creating an object. Then after that, everything is bound to that constructor until you create another object. We agree? Hello?
Yes.
So,
yes.
I don't think, well, in my experience, I don't think it's advised to use that, use the arguments in the constructor for creating an object. Maybe you would give an example for me to really understand what you are talking about. Because when you are creating an object, the constructor is like creating the platform for your object to sit, right? And then you expect to use the arguments in the constructor. What would be the use of those arguments?
I don't know. What's my question?
Yeah, because I don't think it's good programming practice. You create a constructor, right? You set a few things. It's like an initialization of whatever you are doing with your object. Then you want an object to rely on the constructor arguments. That's why I'm saying I'm trying to see the usage of such a situation whereby you would need arguments passed in the constructor to use them in your object. So it's not very clear. Maybe I will have to check if I can get an example of that scenario, but I never came across that example as of now.
Okay.
Then the second question, the depth of member functions. Depth of complexity. I think if you are asked to demonstrate, there are some pointers or basic structures which you have to illustrate the understanding of a certain concept. For example, let's say we are talking about a virtual function or a pure or an abstract class, right? So for you to demonstrate an abstract class, we said you need a pure virtual function. So basically, that is what we are looking at. The rest, if I don't ask you to write a runnable program, then the rest will just be trying to show the structure of the class, not necessarily going deep into the other implementations, which do not help in demonstrating what you are asking.
Okay, thank you, sir.
Okay, fine. Anything else?
No.
Nope.
Okay. So this was just a rundown of what I think we could also need to use. Like I said, the basics, we covered them. So if you are still good to go, we can now start on arrays. Okay? With everyone, of course.
Yeah, it's all right.
Yes, it's okay.
Right. So we can say that we have done the basics of object-oriented programming. So now we're just trying to illustrate how you can make.
Hello, sir. Sir.
Hello.
Hello,
Yes.
sir. You're breaking up on this side.
I'm breaking. Hello.
I can hear you perfect. Yes.
Yes.
Right. So what I will do with this one is I will show the issue of arrays. Then after that, I'll give you the PDF file which has the example programs. Okay. Is that clear?
Yes.
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 I see my screen there.
Yeah.
Yes, we can see it.
Yes.
Which one I think was arrays in C++, is it?
C++ arrays.
Yeah, sure.
Okay. That's fine. Let me set up and what happened with my screen here. Hold a bit. Are you still seeing the same screen?
Yes.
All right. Okay. So we'll look at arrays in C++. Then after this, I'll then send you the PDF file, which is the example programs. Right. So we know that an array is a collection of values with the same data type. I think that is known from our C programming. For example, they can be of type integer or Boolean and so on and so on. So again, if you remember that we said an object can also be treated as a variable of data type of the class, it means you can also create an array of objects. You remember that, right? So we refer to all stored values in an array by the name of the array. That means if you are talking about everything in the array, you refer to it by the name. But then if you go to the elements of the array, then what it means is you refer to them using the index, where index number 0 will be pointing to the first element in the array. I think that is a revision. So what we need to specify when you are declaring an array is the data type of the array, that is the values which are stored there. Then the name of the array, you just use any other name, but we said it's advisable that you use a name which will remind you about what is in that array. Then the dimensions of the array. Normally we deal with the one-dimensional array, which just a list of values, or 2D arrays, which might be a matrix or a table. And you can go as far as you want. So in your practice, you can see other 3-dimensional arrays and the like. And when you go deeper into programming, even more diverse arrays. Then the next thing you have to show is the size of the dimensions. So if it's a 1D or a one-dimensional array, then the number will be showing the number of arrays. So int x10, like we said, is an array of integers named x with size 10. That means it can take up to 10 elements. Then GPA 30 can also store 30. With here we said students can store 30 anything. Then students score 30 and 50. This now becomes a 2D array, right? Which stores, which is 30 rows and what? 5 columns, right? That means you have 30 students and 5 maybe scores or marks. So if it's a 2D, that means these are the rows and these are the columns in your array. So you can see that you can actually create a table by using those arrays, right? Then we use one-dimensional arrays to store lists of data values. You can do it in different ways. One can say int x4, that means all the values are named x, but each value or each element is its name given by its index. X0 is called 10, that means the first element is 10. X3, it means the fourth element is 30. And, this is well known. So if you were to show that list, that is what you would see on the list. Then there's a common error when you are trying to access arrays, whereby if you are given an array with, say, 5 elements, there's always an error of trying to access the 5th element using the index 5. So we know that the highest index that you can have in an array is n-1, or the size -1, because we always start at 0 when pointing to our elements. So there are 2 common ways of initializing one-dimensional arrays. I think we talked about that, right? Whereby you can use a loop if there is a certain order which can be followed in giving values to those arrays. Let's say you want to count 0 to 10. Instead of writing 1, 2, 3 and the like, you can just use a loop where you'll be incrementing by 1 and increment the value. Or you can specify the values. So in x10, 1, 2, 3, 4, 5, up to 10, you have specified the values. So you've also initialized your array in giving the values like that. Or sometimes you are not sure how many elements you need. So you don't limit yourselves, like in Y, just say Y, you leave the brackets empty. And that gives you the flexibility of creating different sizes of arrays. And in that case, the number of elements in that array are determined by the values that you use in your initialization, right? Then, if you initialize, let's say, an array of 100 elements, then you just put 0. That means the first element is 0 and the remaining ones also become 0. If there's an array of 20 elements and you initialize the first 3 like 5, 3, 1, that means the remaining will become 0. That means the default value of an element of integers, and I could say all numbers will be equal to 0, right? But then if it's a Boolean array, if you specify the first few, the rest will be initialized to false. That means that is the 0 in terms of the Boolean. So when you are storing elements in an array, it is wrong to try to store an array using the name of the array, unless you are overloading the operator for that. The correct thing would be you store using an index. So int x10, that means that value which will be taken will be of element number 11 in your array. Or you can just use read the values using a loop. That means you increase your index and pick the element in an index as you go. Also, when you are displaying the values, if you use the name of the array, then it will be wrong. But you can use displaying using the elements. Remember, the array is a memory space, so you have to point to a certain storage so that you can pick an element or a value in that array, right? So as an example, we have an array to read values and print them in reverse order. Right, so int x5, that means our array is called 5, is called x, it has 5 elements. Then enter 5 integer values. Then you can use the cin to pick the values which have been entered. So you enter your values, then to pick the values as you enter them. And the values in the reverse order, well, you can do anything else. That one will now depend on the algorithm which you are using to print those values in a reverse order, right? Then passing 1D arrays to functions. By default, arrays are passed to a function by reference, even though we do not even write the reference operator, the ampersand in front of the array name. So this is because the arrays will store a large number of values, and it's faster to pass arrays by reference instead of wasting time and memory copying values into one array, right? So the following signature accepts an array X as a reference parameter, and it also accepts the number of entries in the array. So it's void X process takes an array as a variable and also the number of elements in the array as a variable. So once you pass the array by reference, then you can also now deal with the different components of that array, right? Are we together up to now? This is the revision, I think. Right. So if you say void process int 10, it means that this will just process an array of 10 elements because you have already predefined the size. So if you need an array to different sizes of arrays, you would rather leave it blank like this. Then you can manipulate that as the size varies, and this becomes simpler. So that is an example program where you are passing parameters, prompt, and the array X and an integer N to the function display. So cout prompt for int I is called 0 less than n and the like. You give the value of xi. That means the elements will be from I is called 0, that means x0 to x of n minus 1, and you can display those elements by using the loop. So you can see that in most cases, we manipulate arrays using loops instead of writing one element at a time, right? So in that example, int v7 is an array of integers named v, there's 7 elements. So it is initialize only the first 4 elements, which means the remaining 3 will become zeros. Then W, it is initialize everything, meaning to say it will give you all the values. Then if you call display, then the values of array V. So if you look at display, this will be your prompt, right? So this will be the variable prompt, and this will be the variable V for the array, right? And then the size of the array there. So it will take the value, the name of the array, and then the 7 values that the array will take, 1, 2, 3 up to there. And also here, this will be the prompt here, and then the name of the array will be the variable here, and then the number of elements in that array, and it will print like that. So that's how you can display an array. Instead of going element by element, printing 1, 2, 3, and the like, you can just use that kind of scenario. But as you can see, you should include this header file for you to be able to do those things. Otherwise, sometimes you won't be able to run the program if you don't have that IO manipulation header file being included in your program. Right. So it's also a good idea to pass arrays as constant reference parameters if you want to assure that the function will never change the values stored in the arrays. So you realize that sometimes when your program becomes big, you might end up overriding the values of an array. So say, let's say you now say x15 is about 7, then that means the value will be changed in that array. So to avoid that, you use the const or the constant keyword, so that this array will not be changed by your program. And then that is if you are very sure that your array should not change as the program runs. So maybe there are some other values which you want to use, but which you don't want anyone to modify. And that's how you use them, right? Now, in the array manipulation, you can now use arrays for searching elements in an array. Basically now the issue with arrays here is it's the strength of the algorithm which you'll be using to search for values. Otherwise, there's not much which I can teach you on searching for values and the like, but these are just examples which show you how you can manipulate an array. So in this case, we are saying you want to search for a smaller value, for the smallest value in the array. You can do that using that algorithm. I know you can use any other different algorithms to do that. So in this case, we are using a function called min, which is defined here. So when you make a call to that min, it will take the array name, its size, and you start at 0, and you start searching for the minimum value. So this algorithm is not a standard algorithm. You can use any other algorithm, but what you are saying is you can still use those arrays to search for values, right? So the array is not sorted. First, we use the parameters to start to specify the start searching index. The 0 is the default value of this parameter. Later on, we'll use this function to sort an array, right? So here you can use sequential searching. That means you go from 0 up to the last element in the array. You are searching and comparing one array after another, get the minimum, right? So the function will return the index of the first value that equals to the key. It exists, otherwise it returns as 0, right? So in this case, you enter a key, and if that key is there, then it will be returned, right? So I'm sure that's how it also searches for other things like you can use that to get PIN numbers, passwords, and the like. So someone enters a password and you have stored the password somewhere, then it goes and searches if there's a match, then it can allow you to do anything else. So those are some of the things that you can do with arrays. So you see if there's a link between a name and a password, then you can allow access or stop someone from accessing there, right? So you can do also a binary search and the like, just other ways of manipulating arrays. So the array X must be sorted. Then each loop iteration eliminates half of the current length of the array, which makes this searching technique more faster than the sequential search. We stop searching when left is greater than right. In this case, we return -1 to indicate that we could not find the key in the array. So like I'm saying, these kinds of programs can be used looking for passwords, softwares, and even when in access control, if you're doing an access control program, maybe you have a card, then you have maybe a 4-digit number which you should enter. So you just enter that, you swipe your card or something, you enter the digit. Then an algorithm will search, see if there is a match. In other access points, they just search for the number that is picked. Also, maybe a card will pick if the barcode. So it will just search, there's a barcode like that, you are allowed access and the like. So you can use some of these things in your program. So as we go, if you have a similar thing in your project, you can still do that. And also you can use arrays in computing, addition, multiplication, and the like. You can still use these kinds of things to do that. So compute the standard deviation of an array, and you realize that you have to know how to calculate standard deviation in the first place. Then you can use the whole algorithm to do those calculations. So the advantage now will be you just go into the memory, you pick element number 1, element number 2, and the like. Whether you're adding them or subtracting, it's up to you. But it saves you time. You store the array once, then you can pick values as you go. If there was no array, that means you have to make all the data available wherever you want to use it. And compute median and the like, this is just the algorithm. I will not dwell much on. And then again, you want to show that you can still refer to your array elements. So say x n over 2, that means n over 2 will be the value there. That value now will be used to pick the element in that index, and so on. You have more examples in the PDF file, which I will send you after this. Multiplying an array by a constant value. So what this simply means is that each element of the array will be multiplied by that value. So let's say you want to say 0 to 10, then you want to get maybe 0 to 100. That means you have multiplied every element by 2, by 3, by 4, and the like. So if you see, you can do a multiplication table using that. So if 1 to 10, right? Then the next row you are multiplying by 2. So if you say xi times is called value, then if you are printing that, so your first row will be 1 to 10, the next one will be 2 to 20, the next one 3 to 30, and the like, then produce a multiplication table in a simple way, and so on and so on. Then you can also use it in dealing with matrices. In your mathematics, you can still use arrays to do that. You can also add or subtract two arrays, right? So add a component by component, like zi is about xi plus yi. That means element number 1 will be equal to element number 1 in x plus element number 2 in 1. And also, if you need the difference, you can do that again, manipulating arrays. If you set an intersection, that means you want to see where the two are equal. Again, you can use the for loop to check there is equality, and you pick where the two are intersecting, and so on and so on. So basically, these are just examples of what you can do with your arrays. I'll convert this one again to PDF, then you can play around with these values. Then after that, on our WhatsApp platform, you can now send me any questions when you think the program did not behave as expected. Converting integer to a decimal, binary number, and the like. So all you have to know are the methods of doing it, and then you create an algorithm. You can use arrays to perform whatever you need, so on and so on. So those are still examples in that case. Again, you can find the largest number. It's not very different from the smallest number. Search. So this one was an exercise. You might not need to do it, right? A function will say the smallest value stored in a 1D array. The function signature should be like this: int smallest. You take the array and its size, then find the smallest value. The input an array, its size, and output will be the smallest value. Maybe you can do that as a practice exercise, just to show how you can do that. So just searching for index of the largest value in a 1D array. So again, you see that you need this IO manipulate header file in most cases, so that the program can run well. So index of max value, it takes the index, the array and its value and its size. So assume for a moment that the largest value stored is in x0. So this is just an algorithm. You can write your own different algorithm which does the same thing. So int max is called x0. So you are saying the initial value of your maximum value is in position number 0. Okay, position number 1, so to say, or at index 0, right? Then the index also you initialize it to 0. Then for I that the index is equal to 1 and less than the size, you increment the index. So why do we start at I is equal to 1? Because already we've initialized for max and that at 0. So if max is less than xi, because we have said the max is already at index number 0, so we have taken the value of max as the value at index number 0. So do not need to start at 0, you start at 1 because we'll be comparing to the initial value. So if the max is less than xi, that means, let's say for element number 1, if element number 1 is greater than element number 0, then it means the value of max will be the value in index number 1, right? And then your index will be equal to say 1 here. Then you go back, because we have incremented now, our next I will be equal to 2. Now we are comparing value at index number 2 to value at index number 1. That is if index number 1 value is greater than max. If it is not greater than max, it means the value of max is still at the value of index number 0. And you go through that until the end, and then you return your index in your program, right? So after that, then you can print the value of the index. At the maximum value of the index is the index number whatever, depending on what you want. So here we're just showing a function which can validate the position. In this case, it's not returning the value, but it's returning the position of the largest value in the array. The now exercise, write a function to search for the index of the smallest value. So in that case, if you look at it closely, that means in this case, you can only change this to greater than, and everything will become, you will be looking for the smallest. You can see, just change this sign, then you're picking the smallest value, right? Insertion sort, right? In that case, again, the swap is also in the IO manipulation header file. So if you just say swap without the IO manipulation header file, again, your function will not run properly. So the index of the large value stored in the range of 0 to n minus 1, swap this value in that index with xn minus 1. That's explain what this program is doing. So I think for that, we can end here in terms of the arrays. Then I'll convert this file and also the other file, which is main programs, convert them to PDF. Then you can use them as your examples from now up to the next Friday. Next Friday, we'll be looking at pointers. I think after that, you can do your projects and you'll be also ready to write the exam. Okay, that's it for today, unless we have questions.
Thank you, sir.
Thank you, sir. No questions on this side.
Okay.
No question this side.
I think we are fine. Now, I didn't get many questions from people about their projects, and I didn't get many responses. What is happening with the projects?
I think we have more questions concerning the assignment.
Assignment, you ask questions after submitting.
Okay, so the question about the employees thing, is this supposed to be a complete program or just a small bit? Because I feel like the Toyota program is and it's long.
What's your actual question there? What are the questions saying, by the way?
Okay. Yes. Mewana.
I think what I have is the test. I hope I'm not sharing my screen. The assignment. Where is it now? I can't see it. What was the name of the file, by the way?
Assignment 2020.
I think I sent it to my assignment 2020. Okay, question number.
Assignment 2020.
Okay, question number what?
Oh.
Okay, create a class employee.
Can someone help me?
Okay, I think I got it. Create a class employee with the data members, employee ID, name, designation, and salary. Write methods: get employee to take the user input, show order to display grade of employees based on salary, show employee to display employee details. Right? That correct?
Yes.
Yeah. So
yes, sir.
What's the question now?
So I'm asking, is this supposed to be a complete program or I
say create a class. You have to create the class first.
Yes, for it to run, it has to have everything.
No, and this one is the written thing. So
Irritated.
And you are writing it. I'm not saying I need the running program. Did I say that?
No, but don't go to me like a screenshot.
Put a screenshot and you write the program in Word and send it for marking as if you're writing it on paper. If you are writing a program and running it, it's fine for your own practice.
Okay. Okay.
What were you doing? So everywhere where there's need for a program, you're running the program and running it.
What?
So,
yeah,
it's still fine for practice. It's still fine. But what I want is you type everything. I want to read the program and see if you can demonstrate what I want to see. Only that.
Okay. Cool. 5. Number 5.
Yeah, still write it that way. I know what I'll be looking for in your program. But if you can write it and run it, then that will be good for you because you'll be sure that this runs. But for me, there are things which I want to be demonstrated, which might not, the program might not necessarily run there and there, but it should demonstrate that you know what you are talking about when you talk about destructors, when you talk about virtual functions and the like. That okay?
Yes, thank you for the highlights, sir.
Right, anything more? Then I will convert this one to a video, but now I'm just wondering, do you want it to go public like the previous one, or I invite people to access it on YouTube?
Not public. Not public.
So we have YouTube channels now where I can invite you. Hello. Because if I put it on YouTube and I'll make it private, right? But then for you to access it, then you have to seek my permission. You request. That okay?
Yeah, it's fine.
Then you tell the others that they cannot access it straight away. They will have to go on the video, then they put a request to access, then they can access. So that means I also change the attributes of the previous video so that it becomes private, so that not everyone will see it, Angie.
Okay.
That okay?
Yeah.
Right, I think
Yeah, sure, sir.
we are fine. Anything else before we log out?
Not that thing.
Stay home and stay safe, sir.
Thank you. He said they don't move around. Corona does not end with the lockdown loosening of conditions. It might even be worse. And do you know that?
Yeah.
Okay, cool. Let's do that. I'll send the files. I'll send the files on WhatsApp. But for the video, hello.
Yes, sir.
For the video, then I'll do what we've talked about. You have to ask for access, but I'll send the link to you. When you want to access it, then you put a request, then I'll grant you. Okay?
All right.
Fine. Enjoy your days.
Same to you.